Okay, this is lesson 4.3. It's about dividing polynomials. The objective is students will use long and synthetic division in order to divide polynomials and determine factors. So in the last lesson we multiplied polynomials. So in this case we took x plus 1 times x squared plus 2x plus 3 and came up with something like x to the third plus 3x squared plus 5x plus 3. And this time we're dividing, which means we're going the other way. We're taking that x to the third plus 3x squared plus 5x plus 3, and you divide it by the x plus 1, and the answer should be x squared plus 2x plus 3. So how do you do that? And in order to remember how to do that, in order to teach you how to do that, what I'm going to do is we're going to go back and we're going to think about how you did long division when you had numbers. So here's a simple long division problem. And the first thing you did is you took the first 9, you divided by 8, you got 1, and you put that on the top. And you multiplied that 1 times an 8, and you wrote that underneath. You have 9 and 8, you subtract, that gives you 1, and then you bring down the next digit. So then you divide the 19 by 8, which is 2. 18 times 2 is 16. You subtract those two numbers, you get 3. Then you bring down the 6. Then you take the 36 divided by 8, you write 4 at the top. 8 times 4 is 32. And then you subtract those, you get 4. You bring down the 0. 40 divided by 8 is 5. 5 times 8, write it down there, is 40. You subtract those, and your remainder is 0. So we're going to do that same thing, but instead of dealing with one digit at a time when we're dealing with a number, we're going to deal with one term at a time when you deal with polynomials. So I want to divide x squared plus 3x minus 18 by x minus 3. So I'll write it the same way. I have x squared plus 3x minus 18 underneath the bracket. I have x minus 3 on the outside. So I look at the first term. X squared divided by x is x, so I write that on top. Then I multiply that x times x minus 3, and remember when I do that I have to distribute, so I have to multiply times both terms. So that becomes x squared minus 3x. Now you have to remember what you're doing now is you're subtracting. So I'm doing x squared minus x squared, that's 0. But I'm also doing 3x minus negative 3x. And 3x minus negative 3x is the same thing as 3x plus positive 3x. So that's 6x. Now that I subtracted them and got an answer, I bring down the 18. Then I do 6x divided by x, which gives me 6. So remember, I'm doing this by terms, so I put plus 6. And then 6 times x minus 3 is 6x minus 18 after I distribute the x. I subtract it, and I get 0. So let's do one more, but it's a little more complicated. So I'm going to have x to the third plus 3x squared minus 6x minus 3 divided by x plus 4. So first I divide x to the third divided by x, and that's x squared. I multiply x squared times x plus 4, so that's x to the third plus 4x squared. I subtract, so 3x cubed minus x cubed cancels out. 3x squared minus 4x squared is negative x squared. Then I bring down the next term. So I have negative x squared minus 6. And negative x squared divided by x is negative x. So I do negative x times x plus 4. So that's negative x squared minus 4x. And I subtract again. Remember, I'm subtracting. So negative x squared minus x squared is 0. And negative 6x minus negative 4x is negative 2x, because that's the same thing as adding. Then I bring down the next 3. So I have negative 2x minus 3 divided by x plus 4. So I have negative 2x divided by 4, that's negative 2, so I put that on top. Then I multiply the negative 2 times x plus 4, so it's negative 2x minus 8. Then I'm going to subtract. So I have negative 2x minus negative 2x, 0. And negative 3 minus negative 8 is going to give me 5, because remember, minus negative 8 is the same thing as plus 8. Okay, now there's nothing else to bring down, so that 5 is my remainder. So the answer is x squared minus x minus 2, remainder of 5. Here's one for you to try using long division. I'll wait a second and you can pause the video before I put up the answer. Okay, you should have gotten that the answer is x minus 16 with a remainder of 0. Now we can use division and remainders to see if something is a factor of something else. So for instance, if I take 2,484 and I divide by 4, I get 621 with no remainder. That means that 4 is a factor of 2,484. But if I take 2054 and divide by 4, I get 513 with a remainder of 2. That means 2054 is not 4 is not a factor of that number. So we can do that same thing with polynomials. If I divide the polynomial and it goes in evenly, then it is a factor. But if I divide the polynomial and there's a remainder, it is not a factor. So for instance, I want to find out if x plus 4 is a factor of, I will do a, x squared plus 6x plus 8. So I divide. X squared divided by x is x, and then I multiply that x times x plus 4, that gives me x squared plus 4x. When I subtract, I have 2x, and I bring down the 8. Okay, divide that by 2x by x, I get 2. So 2 times x plus 4 is 2x plus 8. I subtract, I get 0. There is no remainder, so x plus 4 is a factor of x squared plus 6x plus 8. So why don't you go ahead and take this time and do the same thing for b and see if x plus 4 is a factor of that polynomial. Wait while you pause the video. Okay, you should have found that it is not a factor of that polynomial. The remainder was 1. So here's another way to think of doing division. It's not as intuitive. You don't have the x's, so it's not as easy to see what's going on, and it's not based on something you've done before. But once you get the hang of it, it ends up being a lot faster and usually a lot easier for most people. And it's called synthetic division. When we do synthetic division, we don't use x's at all. We only use the numbers that are here written in the paper. We draw the division sign upside down, and you leave space for 2 lines worth of numbers inside the L. On the outside of the L, you write the root or the 0 of the factor that you're dividing by. So if x plus 1 is the factor you're dividing by, then negative 1 would be the root of that factor. Remember, x minus a is the root. Then you have to write the coefficients for each of the variables in descending order. So 3 goes with x to the third, negative 4 goes with x squared, 2 goes with x, negative 1 has no variable. So you write them in that order, and now from here on you bring down the 3, and now you just multiply and you add. So every time you bring a number below the bar, you multiply it times the root, the negative 1 that you put on the outside. So negative 3 times 1, 3 times 1 is negative 3, and we put that under the next number. Then we add. Negative 4 plus negative 3 is negative 7. Now multiply and add again. Negative 7 times negative 1 is 7. 7 plus 2 is 9. 9 times negative 1 is negative 9. I add those together, I get negative 10. So these are the coefficients of my answer. But the thing to remember is that since I divided x to the third by x, I know my answer is going to start with x squared. So the answer is always going to be 1 less exponent than the original problem. So in this case, the answer is 3x squared minus 7x plus 9, and that negative 10 is the remainder. So here's another answer question to do. Why don't you try it on your own and do synthetic division? Okay, now that you come back, you've actually done this problem before. It's still x minus 16, remainder 0. You just use synthetic division this time instead of long division. So here's a word problem we can attack using synthetic division. The volume in cubic feet of a sarcophagus, which is a fancy name for a coffin, can be expressed with a product of its 3 dimensions. V of x equals x to the third power minus 13x plus 12. So the length of this sarcophagus is x plus 4. So we want to find the linear expressions with integer coefficients for the other dimensions. So we want to find the width and the height. So we know that x plus 4 is one of the factors, so let's see what happens when we divide by x plus 4, and we'll be left with something that we might be able to factor. So in synthetic division, we put negative 4 on the outside because that's the root, and then we have 1, 0, negative 13, and 12. The 0 is important because if you look at the original problem, it's x to the third minus 13x, and you see that they skipped the x squared term. But when we do synthetic division, we can't afford to skip the x squared term. We have to write them all. So if the original problem has no x squared term, we put 0 for the x squared. Okay, now we bring down the 1, and from here on out, it's multiply and then add. So negative 1 times negative 4 is negative 4. Add, it's negative 4. Negative 4 times negative 4 is 16. Add, negative 13 plus 16 is 3. Now negative 4 times 3 is negative 12. We add those, we get 0. That means the remainder is 0, which is good because it means that this is a factor of that original problem. So now we have to translate that back into the mathematical language. And since we started with x to the third, the answer is going to be x squared. So this is x squared minus 4x plus 3. To take that one step further, x squared minus 4x plus 3 is something that we factored in the last unit. So we need to look for two numbers that multiply to give us 3 but add to give us -4. Now since 3 is positive and 4 is negative, I know both numbers are going to be negative. So 3 is prime, so this actually makes it pretty easy. It has to be 1 and 3, and since they're both negative, it has to be -1 and -3, which add to give me 4. So this is x minus 1 times x minus 3 times x plus 4. And that's my 3. That's my length, as I said. That's my width. And that one is my height. And I've solved the problem that it asked me to solve. There's one more thing we can do with synthetic division that works out a little bit faster than working it out the old way. And that's finding the value for functions. So if I tell you that f of x is x to the third power minus 4x squared plus 5x plus 3, one way to find f of, say, 2 is to plug in 2 for every single x. Then you have to take a step-by-step process to simplify that out and get me a one-number answer. So 2 to the third is 8, 2 squared is 4. Right, then you multiply out. So 4 times 4 is 16, 5 times 2 is 10, the 8 and the 3 remained unchanged. So now you have 8 minus 16 plus 10 plus 3, and if you add those all together, you get 5. That's one way to do it. Now here you can use synthetic division to do it the same way. So this is the remainder theorem. If we use 2 as our root on the outside of the synthetic equation, synthetic division bar, then we're going to get the remainder is going to be our answer. So for instance, I use 2 as the root. I have 1, -4, 5, 3. I bring down the 1. 1 times 2 is 2. Add those together, I get -2. -2 times 2 is -4. Add those together, I get 1. 1 times 2 is 2. Add those together, I get 5. So the remainder is 5, which means f of 2 is 5, just like I found it the last time. That's all we got for today. Here's the homework. Page 1 through 4 is going to ask you to use long division. And page 76, 5 through 9 is going to ask you to do synthetic division. I want you to please try to do both ways. Get them under your belt, get some experience doing both, and not just learning both, but actually using them. Because my guess is long division probably makes more sense right now, but after you get some practice, synthetic division will probably be quicker and easier for most people. So good luck, and I'll see you next class.